Good morning. Today we're going to take the derivative of y equals x raised to the power of the sine of x. We're going to have to use logarithmic differentiation. I really am unaware right at present of another way to do this. We have a variable raised to a function with a variable in it, which it's a trig function too, so this could get interesting. So to use logarithmic differentiation, we first take the logarithm, natural log of both sides. I guess we don't really have to, but it always seems to make sense. So we have the natural log of y equals the natural log of x raised to the sine of x. I just thought if we didn't use the natural log, then we'd have a 1 over the logarithm of the natural log of the base when we took this derivative implicitly on this side. Anyway, so it kind of makes it sloppy. So now we can use properties of logarithms to pull down that exponent. So we have the natural log of y equals the sine of x times the natural log of x. Now we have we can take the derivative. We derive this side implicitly. We use the product rule on this side. We're deriving with respect to x. So the derivative of the natural log of y with respect to x is y prime over y. I hope that doesn't throw anybody up. It's 1 over the argument, which is 1 over y, times the derivative of the argument, which is, we don't know what y is, so it's just y prime. The derivative of y with respect to x is just y prime. So then we'll use the product rule over here. The derivative of the first is the cosine of x, times the second, which is the natural log of x, plus the derivative of the second, which is 1 over x, times the first, which is just sine of x, times 1 over x is sine of x over x. I realize I'm probably skipping steps, but oh well, I like logarithms. I don't know what that had to do with anything, but anyway, I don't know. I do like logarithms. You get to be kind of creative with them, as far as it's a matter of opinion sometimes of the way they look in the end. Can change sometimes they make more sense. Anyway, sorry. Now I've multiplied both sides by y, solving for y prime, so I have y prime, which is what we wanted, the derivative, with respect to x equals y times the cosine of x, ln of x, plus sine of x over x. We know what y is in terms of x, so we just substitute that back in. We get y prime equals x raised to the sine of x times the cosine of x. You could get a common denominator. I choose not to in this part. I don't know why. It wouldn't be hard. But anyway, that's it. That's the derivative.